The last clip was a little bit short, but what we're showing is that for the function f of xy equal x squared plus 4y squared, level curve x squared plus 4y squared equals c can be solved for y, getting y equals plus or minus 1/2 square root of c minus x squared. Simple process, subtract x squared from both sides, divide both sides by 4, and factor the 2 out from under the square root. In other words, square root of 1 over 4 is 1/2. And we get the plus or minus. Now this is going to correspond to our ellipse. Okay, we have the upper half, which would be y equals plus 1/2 square root of c minus x squared, and the lower half. We can easily enough take the derivative. We're going to use the chain rule. Our inner function is c minus x squared, which is going to give us a factor negative 2x. Notice I carelessly wrote down a square on that before, but I've covered that. Okay, and you have the plus or minus 1/2 out in front, and the derivative of the square root is 1 over 2 times the square root. Just careful application of the chain rule gives us this expression for dy dx. Of course, here we've divided the 2's out here. We still have a plus or minus. Actually, I should maybe call that minus plus, because when we have the plus here, we're going to have the minus down here, and so forth. However, we understand that the derivative at a point x, y, the point actually being x plus or minus 1/2 the square root of c minus x squared, will be one of these two values. So we can say at the point x plus or minus 1/2 square root of c minus x squared, slope is one of the values plus or minus x over 2 times the square root of c minus x squared. This means, for example, if we're on the upper half of the curve, and that curve would be y equals plus 1/2 square root of c minus x squared, then at a point on that curve, and the point would be denoted x, in this case plus 1/2 square root of c minus x squared, the slope of the tangent line is, in this case we see that the slope is positive, so this corresponds to a negative value of x and a positive value of y. The slope of the tangent line is plus 1/2, and it's going to be x over the square root of c minus x squared. That's kind of small, so we'll pick that up on a slightly larger picture. I've gone ahead and drawn a graph of the upper half of this function. The lower half would simply be the rest of the ellipse. It's not particularly well drawn. The thing should be tangent to a vertical line here, and I didn't quite bring it over far enough. In any case, this point here for the curve x squared plus 4y squared equals c, and that's of course the upper half being y equals 1/2 square root of c minus x squared. If x equals 0, then y is 1/2 the square root of c. So here y equals 1/2 square root of c. At this point, x equals the square root of c. This is the point where y equals 0. Y equals 0 if c minus x squared is 0, which occurs when x is plus or minus the square root of c. And actually in this case, x is negative square root of c, here we have x equals plus the square root of c. Just to get oriented with regard to this picture. Now, again, if we have the point, some point x, y on the curve, our tangent line has slope that's equal to the value of the derivative at that point. At this point, in the second quadrant, we see that the tangent line is always going to be increasing as we move to the right. The slope of the tangent line will always be positive, so we have slope of the tangent line is positive the derivative. Now remember, the derivative is plus or minus x over 2 square root of c minus x squared. We're going to have the positive at this point. So it's going to be positive x divided by 2 square root of c minus x squared. And that's going to be the slope at this point. If we chose the point symmetric with this one, if x was equal and opposite to this value of x, we'd have the negative slope. I'm not going to draw that. If we're below the axis on the part of the curve for y equals negative 1/2 square root of c minus x squared, in this quadrant the slope would be negative. We would choose the negative of the we'd choose the negative of the positive negative on this expression for the derivative. And if to the right, if in the fourth quadrant, the slope would be positive. At this point, you might be asking the question I'm going to pose next: what does this have to do with the gradient? Well, we're going to check that out in a minute. But what we expect is that the gradient of this function at this point should be a vector perpendicular to this tangent line, so that the slope of the gradient of a line in the direction of the gradient should be the negative reciprocal of this slope.